Welcome to Leetcode JavaScript, the channel where we solve every single Leetcode question using JavaScript. Today we have 433, minimum genetic mutation. This is a medium question. So a gene string can be represented by an 8-character long string which chooses from A, C, G, and T. We suppose we need to investigate a mutation from gene string start to end, where one mutation is defined as a single character being changed in the gene string. For example, we have two strings where only the last character was changed from a T to an A, and that's considered one mutation. For a gene mutation to be valid, it has to be in the bank, and the bank just records all the valid gene mutations. Given two strings, start and end, and the gene bank, return the minimum number of mutations needed to mutate from start to end. If there is no such mutation, we have to return -1. And we also assume start is valid, so it must not necessarily be in the initial bank. So to say this a bit more clearly or more simply, we have two strings that can only have A, C, G, or T as valid characters. And we want to know whether by changing a single character at a time, we can reach end with the caveat that every single change or intermediate steps that we have to be present in the gene bank, and that also includes the result itself. Both the intermediate steps and the result itself has to be in the bank, and we just return the number of steps it takes. And of course, if we don't find it, we return -1. So we're gonna use breadth first search as an approach, and for breadth first search we must use a queue. So I'm gonna initialize a queue variable as an empty array. Actually, let's initialize it as both start and 0. Remember, you can use an array as a queue in JavaScript, and the first element that we're gonna have is an array itself that contains in the first index the current mutation that we're looking at and the number of steps. We start at 0 because there have been no changes initially. Then we're also gonna need a set. I'm gonna call that set mutations. And it's going to be a new set that's created for the bank. This essentially creates a set for all the elements that may be contained in the bank. Now, if you've ever done breadth first search, this might look like a familiar syntax. So we're going to do while queue.length is greater than 0. Now, we want to check the current mutation and the step number. How do we get that? Well, it's relatively simple. We can use the destruction operator in JavaScript. It's called C as the current and S as step. And that's going to be equal to q.shift. And q.shift removes the first element and returns it. So here we have two variables that have been assigned. The first one to the current mutation and the second one to step number respectively. And then we check whether C is equal to end. That means the current mutation is equal to the goal. If that's the case, we return S, which is the step number. Now, we're going to use a for loop to find every single mutation that's valid. And the way to do that is we're going to have a simple for loop. See that line, ++. We're going to iterate through the current mutation. And of course, we start with the initial value. Then we want to change every single character to either A, C, G, or T, and then check whether the mutation is valid. And mutation is valid if it is contained in this set that we declared over here. So we're going to have another inner loop, call it CH for character of, again, A, C, G, or T. Now, to actually change one character at a time, we need to use the following syntax for a substring in JavaScript. And this is going to be c.substring that starts at 0, ends at 0, ends at I, plus the current character, ch, but c.substring that starts at I plus 1. Alright. So now we have m, and we want to check whether this m is valid. The way to do that is check that mutation that has m, if it is contained in the set, then we're going to do two things. First, we're going to do mutations that delete m, because we're only concerned with the first time we find it, so we can make the other current one and just ignore it for the rest of the problem. And then we q.push m as a current mutation and s+1 as a step number. Now, this is going to repeat for every single permutation that we find, and whenever we find a valid mutation, it's going to be added to the queue. Now, if all of these fails and we do not find it, and queue remains empty, you're going to return -1. Let's run this code, and it is accepted. Before submitting, let's go through what we're actually doing once again. We create this queue that has both the current mutation and the step number, and we create a set from the bank that we were given. Then, using breadth first search, we want to check every single mutation that's valid and how many steps it took us to reach to that mutation. And whenever we find the mutation, the first time that we find a mutation that's equal to the end, we're simply going to return S. And we have to permutate every single possible combination or every single change that can be done to a single character and check whether that change is valid. And then we eventually returned it, or return -1 if we never found it. So we're going to submit this. And there you go. The runtime was 100 milliseconds. This is an average speed solution because that's essentially the only way to solve it, or the standard way to solve it rather. Thank you very much for watching. Don't forget to like and subscribe.